Hey everyone, so this isn't an assignment, but I wanted to walk through a few of the word problems just so you can kind of see again how those are set up. Um, so just for some general practice and discussion. So remember with quadratic word problems, we've got 4 different kinds of word problems that we can deal with. And so aside from consecutive integer, I think I have one of each here. The first one is a geometric word problem. So a rectangular building lot is 8 feet longer than it is wide. And so draw a picture with these geometric ones. Give yourself an idea of, are you dealing with area where you have length times width, or are you dealing with something where you need Pythagorean theorem? And so that's equal. Which one is this? Okay. And so if it's 8 feet longer than wide, then if x is the width, then this is x plus 8. The area is 298. So length times width is area. So I'm going to take x times x plus 8 and set that equal to 2900. So x squared plus 8x equals 2900. You're going to get this set equal, well, actually this one is great for completing the square. I'm going to complete the square on this one. So I'm going to take 8 divided by 2, which is 4, and square it, which is 16, and add that to both sides. So now x squared plus 8x plus 16 is equal to 2916. This factors into x plus 4 squared, which is 2916. You take the square root of both sides. Because this is a word problem, go ahead and actually take the square root of 2916. And you're going to get a lot of decimals and fractions with these types of problems. That's okay. This one we actually don't. X plus 4 is equal to plus or minus 54. Now, because we're dealing with length, that minus isn't really going to be helpful to us. So when we get negative 4 plus 54, we get 50. That represents this length right here, which means that this is 58. And you'll see if you do negative 4 minus 54, you get negative 58. So you get that number, just its opposite. And that's just how we had that problem, where we had the x represented. Okay, so this is a 50 by 58 foot lot. The next type of problem that we looked at was your RTD problems. And with this, it's more distance divided by either rate or time. So distance divided by time equals rate. So you have those ratios. So this is kind of a cross between a rational equation and a quadratic equation. We have a little bit of both in here. A jet flew from New York to LA with a distance of 4,200 kilometers. So we know that this is our distance there. And you can set this up kind of in a table. If you look here, we have our trip from New York to LA. We have our trip back from New York. So from LA to New York. We have our rate, a time, and a distance for each. The distance there was 4,200 kilometers. The speed for the return trip was 100 kilometers faster. And so when they came back, they traveled at this speed. When they came back, it was 100 more than that. But the distance has not changed. So we're going faster, but the distance hasn't changed. The total trip, so both of these together took 13 hours. And so we just need to be able to express time so we know what we're adding together. Well, time is distance divided by rate. So we get 4,200 divided by x, and then we get 4,200 divided by x plus 100. I feel like this might be the exact same one I already put in your notes. If so, I sincerely apologize, but I'll keep walking through it. So we get 4,200 over x is, or plus, I do it the more I know it is, plus 4,200 over x plus 100 is equal to 13. okay? And so we look for that common denominator, which is both x and x plus 100, and we're going to multiply that through by each of these fractions. Okay, so here this goes away, and the x plus 100 is the only thing there, so we get 4,200 times x plus 100 plus 4,200, and here the x plus 100 will cancel, and the x will come up, and that's x is equal to 13x times x plus 100. Let's forget the x. All right, so we get 4,200x plus 4,200,000 plus 4,200x equals 13x squared plus 1,300x. And so we're going to solve this out as a quadratic. So 13x squared. Okay, so I moved everything to the right and then just flipped the equation, so my 13 would be positive. But I have 13x squared minus 7,100x, so combining these and then subtracting them here is, this needs to be minus 4,200,000. I wanted this really bad to reduce by 13. It doesn't, but you would just plug this into quadratic formula and solve it out from there. So I'm not going to finish that problem because the numbers are so big and I don't have my graphing calculator handy. But just type this in your graphing calculator. So 4ac all over 2 times a. Odds are you're just going to need the plus because a is positive. If you moved everything the other way and a was negative, you would do the minus instead. So that's a 2a. I'm going to pause it and I'll just put the answer down. So I typed all that in my calculator and I got 600 kilometers per hour. Okay. So you can try that out and make sure you get the same answer. Otherwise, we're going to move on here. So we talked about this in class. An object thrown will always have a formula that looks like this. This is actually also plus the initial height. If that's left off, that means your initial height is 0. So an object thrown or fired straight upward, they're going to assume that's from the ground, even though sometimes like yours, where you hold your arm up is still 3 feet above the ground. But we always just assume it's from the ground. So these are all slightly off, but that's okay. So suppose a bullet is shot straight upward with an initial speed of 800 feet per second. So this is your initial velocity. Its path is shown in a figure in the book. If you want to look at that, I should have told you guys in class, your online book is now available. When does the bullet fall back to the ground? So when does it reach a height again of 0? So we want this to be 0. So 0 equals negative 16 t squared. Actually, I'm going to move all this stuff down. Okay. 0 equals negative 16 t squared plus, again, our initial velocity is 800 t. Always check to see, does that all divide by 16, which it does, because that helps you reduce it. So we get, I'm going to divide by negative 16 minus 50t, because now we can just factor this and solve it. So especially when your initial height is 0 and you just have those two terms. I'm going to take out a t, so t and then t minus 50 equals 0. So it's at a height of 0 when t equals 0, which we know because starting out we're on the ground, so after 0 seconds. But then t minus 50 also equals 0, so t equals 50. So it comes back to the ground after 50 seconds. When does it reach a height of 6,400? So that is asking in that equation, when will this equation equal 6,400? When is it at that height? If you get an imaginary number for this problem or an error in your calculator, what that means is it doesn't reach that height ever. So I'm going to subtract that 6,400 over. And I'm going to divide by 16 again to reduce this down. Assuming, notice I'm flipping my signs as I go through here. I always divide out that negative, even if nothing else will divide out. It's just personal preference. 400. So you can try to factor this, or you can plug it in quadratic formula. It's up to you. With 400 going to 50, I'm going to pause and find those numbers. I shouldn't have paused. It shouldn't have taken me that long. So we have t, change it to next, t minus 40, and t plus 10 would get us that negative, n minus 10, sorry, will give us that negative 50 and that positive 400. So t equals 40 and 10. So again, because of that path, it's going to reach that height of 6,400 twice, after 10 seconds and again after 40 seconds. So 40 seconds and 10 seconds. All right, then it says, when does it reach a height of 2 miles? And so because this is dealing with feet per second, we do have to convert that. So just a reminder that 1 mile is 5,280 feet. And so we're just going to double that as we're using it. So 2 miles. Take 5,280 and times it by 2, and we have 10,560. And that's what we'll plug in. So we want it to reach that height. We're going to do it just like we did B. We're going to say 10,560 is equal to negative 16t squared plus 800t. Okay. Go ahead and solve that out. Okay, so I typed all this. You can see I moved this over, hopefully, and then I divided by negative 16. I kind of just did it simultaneously. I plugged it all into my quadratic formula and saw that I had an error in my calculator. This means it does not reach that height. I'm just going to say it does not reach. DNR stands for a lot of different things. Quickly, but I'll have room to write it all out. So it doesn't reach, never does. Never gets there. All right, and then the last one is D. How high is the highest point? So we haven't really talked about that yet, but I'm going to go through it. Won't be required to know it for this test, though you will see it later on. The highest point of a parabola is that point in the center, that vertex. And so because it hits 6,400 feet twice, we know it's somewhere at least a little bit above that. And so to find that, we can find how long it takes to get to the highest point. So that formula is x equals negative b over 2a, or in this case, t equals negative b over 2a. And so we're going to use this equation. I'm going to use this equation here because it's simplified and it doesn't matter. So the opposite of b is 50 over 2 times a, which is just 2. So 25 seconds. So after 25 seconds, it reaches its maximum height. So to find what that maximum height is, we just plug in 25. And so 25, excuse me, squared minus 50 times 25. So we type that out in your calculator. Sorry guys, I misspoke. I did need to plug it. This part we need to plug into the original equation. So negative 16 times 25 squared plus 800 times 25. You just type that in your calculator and you get 10,000. So this kind of explains, this is the maximum height, so that's feet. We were never able to reach that because this was our highest. Okay. All right, that's it. Hopefully that helped. I didn't really do much but walk through them. But hopefully that gave you a little bit of insight into answering some more of those word problems. I know that these, in my opinion, these are the most complicated because it's not just straightforward quadratic formula. It's combining two different ideas. So if you have any further questions, please let me know. Otherwise, have a good night.